So we got to think back today to when we were in Algebra 2, because we're going to talk a little bit about something called completing the square. Completing the square is a way of solving or factoring something where you create a perfect square term. Okay? So you basically are creating, and if you think about conic sections, all of the conic sections have a perfect square term. That x minus h quantity squared, or that y minus k quantity squared, that is a perfect square term. And we are going to need to create that so that we can put the just a regular old equation into what our conic sections have looked like for the past month. Okay? So, this conic, that's still got to go back, There it is. So, the first step that you are going to do in completing the square is you are going to space out your equation. Okay? And how you're going to space it out is this. You are going to start with the biggest, you're going to start with the biggest termed exponent. So x squared. And you're going to immediately follow that with the next biggest exponent. Then you're going to create yourself a space. And you're going to take the number and you're going to move it to the other side. So you're going to start with, so it's going to look like this. Okay, go.
I want my just it's insurance.
Okay? So that's our first step, is we're going to space out our equation so that we have just variables on one side and the number then moved to the other side. Okay? Then, step number 2. We are going to factor the variable part so that the coefficient on the squared term is equal to 1. So I'm going to look here, and I want that coefficient to be equal to 1. In this particular case, that is done already for us. That will not always be the case. Okay? But that is how we have it done in this one for us, so that part is nice. And when that is done for you. Step number 3 then says, now you're going to look at the b term, or the b number. And b is now the coefficient of the non-squared variable. So b in this particular case is -6. Okay? Because it's the non-squared coefficient. What you are going to have to find is you are going to have to find b divided by 2. So what's -6 divided by 2? -6 divided by 2. -3. So b divided by 2 is -3. We found that one. And you're going to have to find b divided by 2 squared. So what's -3 squared? We got Matthew? 9. Okay. The reason that you had to find those was because that b divided by 2 squared fills the space that you created. So you created a space right here So that fills that space. But now what have I done to my equation? What have I done to my equation? What? I haven't balanced it because I added 9 to one side. So I've unbalanced my equation, right? So how do I get it back into balance? I got to add 9 over here to the other side also. Okay. In the end, or right away, you've got to balance the equation. Okay. Now, what I can do is I can factor the left side. And here's the cool thing about factoring the left side. The left side, or whatever side your variables are on, will always end up being x plus b over 2 quantity squared. That's what that side will always factor. So I've used this one right here. I've used that one in step number 4. And now in step number 5, I'm going to use the other one that I had to find, which is why we had to find them, because we were going to use them. Okay? So the left side of this equation factors to be x minus 3 quantity squared. The right side of this equation is just negative 2. Because negative 11 plus 9 is negative 2. Okay? Now, what I can do is now I can, oops, that's got to come up a little bit. I can square root both sides. A little bit more. But because I'm taking the square root, what do I have to remember? We got to remember the plus minus, yep. Okay. So what is the square root of x minus 3 quantity squared? X minus 3. Don't forget the plus or minus. What is the square root of negative 2? I square roots of 2. Okay, so I'm there now. And lastly, I can solve that equation. Oops, there was that plus minus. And lastly, get rid of that. I can solve that equation by adding 3 to both sides. So I get here x equals 3 plus or minus I times the square root of 2. Now, that is solving by completing the square. You're going to use, we'll do one more like that, okay? But you're only going to use it up to here. Oops. You're going to use it right up to there. You're not going to square root it to solve it. Okay? So you're only going to use it up to step number 4 is where you're going to stop when we're completing the square with factoring. Okay? Solving goes all the way. Factoring stops at number 4. Okay? So, with that being said, let's solve this one by using completing the square. Okay? Step number 1 told me what? Okay, so I need to space out my equation. So that becomes 2x squared minus 28x equals -1. Like that. Agree? Step number 2 says what? Do I need to factor this one on the left side? Why, Sophia? Because my coefficient isn't 1. So if I factor this one, I'm going to factor out a 2, and that leaves me with x squared minus 14x. I still have my space, and it's still equal to -1. Okay? Step number 3. What is my b first? We should figure out what b is first. B is -14. It's this number right there. Okay? So b divided by 2 then is what? -7. B divided by 2 quantity squared is 49. Okay? So now what? Where? To both sides, right? Okay? So where do I put the 49 on the left side? After the 14x. So I'm adding 49 here. Agree? What do I have to add to the right side to rebalance my equation? No. Why is it 98? Because there's two 49s. This 49 right here has a 2 out in front of it. So really, by adding 49 in that space where we had to add it, really we're adding 98. So on the other side, I have to add 98. Because it's that 49 on the left side is being controlled by the 2. Okay? Fantastic. Step number 5 then. I can factor this part right here. This part here is going to factor to be x minus 7 quantity squared. What would I do next? Not yet. Got to do one thing first before we can square root both sides. Divide both sides by 2 first. Now we can square root both sides. Left side becomes x minus 7. Right side becomes what comes first? What do you got? Plus and minus first. Why is it what? Why is it 194? Okay, it's 194 because the square root of 97 over the square root of 2, oops, I put 9. You know, because 2 and 9, they're roughly the same. Okay, so this goes to here, right? And then we multiply by the square root of 2 over the square root of 2, which then gets me that. Okay? And there's nothing, if there was nothing that would, since 97 is odd, it doesn't have a factor of 2 in it. So that is a simplified radical. Okay? Then what? Add 7. But really over here, I'm going to add 14 halves. Right? Right? 14 halves is 7. So that gives me x equals 14 plus or minus the square root of 194 all over 2. Good times. Okay? Okay? Now, where we're going with that is I want us to classify this conic section. I want us to find all the key points. Oops, I guess I took out the graph too. And eventually, I want us to graph it. Okay? But we'll wait till tomorrow to do the graphing ones. Okay? Alright? So first off, let's classify it. What kind of a conic is it? Based off of Monday's class, what kind of a conic is it? Why is it an ellipse? And what? We're adding the squared terms and the coefficients are different. Yes, so this is an ellipse. Okay? So with an ellipse comes what for my key points that I want to know? I want to know my center. What else do I want to know? No? Those are just numbers. I want to know points. We've been doing ellipses for 3 weeks now. vertices, because there's two of them, right? Yep, okay. And the foci. So far, in any ellipse question, I've had you graph it, find me the center, find me the two vertices, and find me the two foci, right? That's going to stay the same. Whatever I've trained you on what I want, that's what I want going forward. So on a parabola, what would I want? Vertex, focus, directrix, axis of symmetry. Okay? On a circle, what would I want? Center and radius. On a hyperbola, what would I want? Center, vertices, foci, and what? And asymptotes. Okay? So whatever we've been doing, we're going to keep doing. Okay? All right. So here we go. Step number one, because it says I got to use completing the square. Step number one tells me I've got to do what? Space it out, okay? So here's how I'm going to space it out. I'm going to say 4x squared minus 48x. I'm going to group my x's together. Then I'm going to leave a space. Then I'm going to group my y's together, leave a space, and put the number on the other side. So how many completing the squares do I have to do? 2. I got to do 2. Okay? 1 for x, 1 for y. There's a rock in my shoe. Okay? Do I need to do a step number 2 at all on either one of the x's or the y's? Step 2 is factor to get the coefficient equal to 1. Shukriya? On the x's I do. Yep, so I've got a factor out of 4 here. Let's deal with the x's first. What's my b value for the x's? So that divided by 2. -6. That squared. Okay. So I have to add 36 there, but really I'm adding 144, so I've got to add 144 on that side. Yes? Okay. Now, look at this b. What's that b for the y's? -14. What's that b divided by 2? -7. What's that b divided by 2? Quantity squared. 49. So in this gap, I've got to add 49. Which means on the other side, I've got to add 49, because that one's not in a set of parentheses. With me so far? Okay. So now I can factor the green part into 4 times the quantity of what? What would be inside my parentheses? What would x squared minus 12x plus 36 factor to be? It's step number 5. X minus 6 quantity squared. What does the y's factor to be? Y squared minus 14y plus 49. What does that factor to be? Y what? Y minus 7 quantity squared. Negative 189 plus 144 plus 49 ends up being 4. Okay? So we're closer, right? What does the general form of an ellipse, because remember this one was an ellipse, what does the general form of an ellipse look like? X minus h quantity squared, then what? Over a squared, keep going, plus y minus k quantity squared over b squared. Here's the kicker, here's the important part, equals 1. So the general form of an ellipse equals 1. How can I get this blue equation to equal 1? Divide every term by 4, right? Okay. So if I divide here by 4, oops, I already used red. If I divide there by 4, I've got to divide there by 4, and I got to divide there by 4, right? Okay. So my general form of this ellipse is going to be, these 4's are going to cancel each other out, right? So that's going to be x minus 6 quantity squared over 1 plus y minus 7 quantity squared over 4 equals 1. Right? Okay? So based off of that, where is my center? Is it stretched out left and right, or is it stretched out up and down? Up and down, because it's bigger on the B, right? So how far up and down would I have to go? 2, right? And that would give me my vertices. So I've got a vertice at 6, 5 and 6, 9. Right? 2 up and 2 down from the vertex, or from the center. Yes? Okay. What's the formula for my foci? So c squared is going to be 1 minus 4. 1 minus 4 is negative 3. Absolute valued is 3. So c squared is 3. What is c? No? Square root of 3. Foci, are they going to be up or down, or up and down, or left and right from the center? What do you got, Matthew? Up and down. So the foci are going to be at 6, 7 plus minus the square root of 3. And if we needed to graph it, we could, but we don't have to graph it. The graph would just simply be, we'd have a center up here, and we'd have an ellipse that looks like that, if we needed to, but it didn't say graph. And that's what completing the square does. Completing the square allows us to take this equation, let's see if I can get it all in one. Oops, I'm so close. So close. Take this original equation, 4x squared plus y squared minus 48x minus 14y plus 189 equals 0. And it allows us to find all that stuff because we put it in a form that, hey now, puts it in a form that we're familiar with. X minus 6 quantity squared over 1 plus y minus 7 quantity squared over 4 equals 1. Which allows us to say our center is there, our vertices are there, our foci are there, and the picture looks like that if we needed to give the picture. Okay? Love this stuff. This is fun math. Tonight is all completing the square problem. So just straight up solving by completing the square, just to get you back into it. So that tomorrow we can do more of finding different conics and putting them in the forms and graphing them and that kind of a thing. Okay? So it's just a more practice of completing the square.